Evolution of CNC machines. CNC machine tools can be operated manually or under automatic control. Evolution of CNC machines. CNC machine tools can be operated manually or under automatic control. After World War II, the NC or Numerical Control Machine was developed by John T. Parsons. NC machines used a series of numbers punched on paper tape or punch card to control their motion. Some of the problems in NC machine are part program mistake, punched tape wear and feeds, less reliable tape reader. To eliminate these, in the year 1960, computers were added to give even more flexibility to the process. Such machines became known as CNC or computerized numerical control machines. In 1968, a mainframe computer is linked to a number of CNC machines to distribute part program to different machineries as required, and it is called as direct numerical control systems. In DNC, the part programs were distributed through the network. DNC eliminates the punched tape reader. In 1970, a small computer with very large scale integrated, that is VLSI, circuit was introduced to eliminate the use of large computers. Computer numerical control machines. In this video, we are going to see about the computer numerical control machines. Computer numerical control machines. Computer numerical control machines are a numerical control method that operates a dedicated computer to execute all basic numerical control functions. Functions of CNC. Some of the functions of CNC are machine tool control, in-process compensation, improved programming and operating features, diagnostics. Machine tool control. The main process of CNC system is to control the machine tool. This includes conversion of the part program instructions into machine tool motion through the computer interface and servo system. In-process compensation. It is closely related function of machine tool control. This involves the dynamic correction of the machine tool motions for change or errors which occur during processing. In-process compensation. The main options are as follows: adjustment for errors sensed by in-process inspection probes and gauges. Recomputation of axis positions when an inspection probe is used to locate a datum reference on a work part. Offset adjustments for the tool radius and length. Adaptive control adjustments to speed and feed. Computation of predicted tool life and selection of alternative tooling when indicated. Improved programming and operating features. The soft wired control has permitted the introduction of many convenient programming and operating features. The main features are as follows: editing of part programs at the machine, graphic display of the tool path to verify the tape, provision of various types of interpolation, circular, parabolic and cubic, support of old customary units and new metric units, use of specially written subroutines, manual data input, that is MDI, local storage of more than single part program. Diagnostics. It is more flexible in the sense that modifications can be made to the program rather than making completely new tape as with older conventional NC systems. The weakest link is least used, that is, the tape is read only once and the program is stored in the memory for repetitive machining. To minimize of downtime, to give warning about failure of components, to contain a certain amount of redundancy of components which are considered unreliable. Now see the block diagram of computer numerical control machine system. The principal components of CNC machines are tape reader for initial program entry, mini or microcomputer and NC part programming, computer hardware interface and servo systems. Machine tool. Working principle of CNC system. It is a microprocessor built with a control system that admits a set of program orders from the punched tape, methods and show output control info to a machine tool. The information stored in the computer can be read by automatic means and converted into electrical signals, which operate the electrically controlled servo systems. Electrically controlled servo systems permits the slides of a machine tool to be driven in the appropriate feeds and direction so that complex shapes can be cut, often with a single operation and without the need to reorient the workpiece. Computer numerically control can be applied to milling machines, lathe machines, grinding machines, boring machines, flame cutters, drilling machines, etc. NC coordinate system. In this video, we are going to see about the numerical control coordinate system of CNC machine. NC coordinate system. The distances or angles which specify the position of a point, line, circle or any other geometrical figure with reference to a series of intersecting planes or planes and cylinders, that is usually 3, define a coordinate system. Calculating the position of tool and workpiece relative to each other and also direction of movement giving the value of displacement, we need to know the coordinates of them. Any controlled movement, whether it is translation or rotation, is known as axis, and coordinate system of axis is established with respect to machine table. Most of the NC machines have two axes, X and Y, for controlling the table movement. Third or Z-axis movement takes place in the tool as in case of drilling machine. For turning, there are only two axes, X for the location of cutting tool radially and for the axis of rotation of workpiece. Z-axis movement takes the cutting tool away from or near to the headstock, and X motion moves the cutting tool axis designation or identification. The purpose of the machine tool is to cut away the surplus material, bringing the workpiece to a required shape, size, and finish. To do this normally, two major operations are performed. The geometrical machine controlled movements, that is, moving the tool and workpiece relative to each other to produce the required shape. Ancillary operations such as changing the feed rates, reversing the spindle, tool changing and turning on the coolant, etc. The first operation has machine movements of two kinds, translation and rotation. The translation is the linear displacement in any of three directions, and rotation is oriented also in three directions, say X, Y, and Z. Three axes of movement identified as X, Y, and Z in NC machines. Certain rules are followed for designating these axes, for applying it to different types of NC machines having different relative motions of tool and workpiece. Linear axis. X-axis. It should be horizontal. It is generally the longest axis of movement of workpiece or tool. It should be perpendicular to Z-axis. It is always parallel to surface of the holding device. Y-axis. It should be perpendicular to X and Z-axis. Z-axis. It is always parallel to the spindle, that is rotary. It should be perpendicular to the X and Y-axis. A thumb rule for Z-axis is that when tool goes near the job, it is Z, that is minus axis, and away is Z, that is plus axis. Rotary axis. In addition to these linear axes, A, B, and C are the other three axes which provide rotary motion about the X, Y, and Z Cartesian axis respectively. It may be noted that all of the axes need not be present in all groups of NC machines. The rotary axes are to be used where the work table or tool head has to be rotated. Machines with rotating tools. In this video, we are going to see about the industrial machines with rotating tool type. Machines with rotating tools. The various machines that come under this type are drilling machine, vertical milling machine, jig boring machine, drafting machine. The machines use a similar type of axis nomenclature. A tool movement is said to be in z-axis on these machines. The movement of the tool into a workpiece is in -z or negative direction, and away from the workpiece is in +z or positive direction. Positive direction increases the clearance between the workpiece and the tool holder. The motion in x-axis direction when looking from the tool spindle to column is positive to the right, as y-axis should be perpendicular to the both axes x and z respectively. The motion of the work table in transverse direction describes the y-axis. Machines with rotating workpiece. Most lathes are horizontal spindle machines. The z-axis for such a lathe will be horizontal. Hence, z is the axis of rotation of the workpiece. The positive movement of the cutting tool, that is z, is away from the headstock. The x-axis is radial and parallel to the cross slide. The x motion is positive when the tool moves outward radially. Again, the rotary motion of job is not defined by an axis, as it is not controlled. There is no y-axis movement in lathes. Machines with non-rotating tool and non-rotating workpiece. The planer, shaper, and slotting machines are the machines which have no spindle. The z-axis is taken perpendicular to work-holding devices which may not pass through the tool point. The x-axis is parallel to the direction of major movement, that is, cutting. Machines have to be installed in air-conditioned places. 0 points and reference points. In this video, we are going to see about the 0 points and reference points. 0 points. It is the origin point of the coordinate system of the NC machine tool. With respect to origin point, programmer decides the tool position and movements. There are two methods of specifying this 0 point: fixed 0, floating 0. Fixed 0, that is M. Fixed 0, that is M, is a 0 point of the NC machine tool fixed by the constructor. It is always located at the same position of the machine tool. For drilling, boring, milling, and similar machines, it is at lower left corner of the machine table, and for turning machines, it is on the spindle flange and on the turning axis. Float 0. It is the 0 point of the NC machine tool set by the operator at any position on the machine. Reference points. There are various reference points for a NC or CNC machine tool as given below. It is the reference points fixed by the manufacturer. This is used to calibrate the measuring system of NC machine tool. Types of coordinate systems. NC or CNC allows two methods of specifying the next location of tool: absolute positioning, incremental positioning. Absolute positioning. Here, the next location of the tool is given with reference to the 0 point. Example: in figure, the coordinate of next location is x is equal to 6, y is equal to 8. Incremental positioning. Here, the next location of the tool is given with respect to the previous tool position origin. Example, in figure, the coordinate of next location is x is equal to 2, y is equal to 3. Depending on the method used, the part drawing should also be impatient accordingly in absolute or incremental methods. It is known as NC dimensioning. Types of CNC machines. In this video, we are going to see about the types of computer numerical control machines. Computer numerical control is applied to a variety of machine tools. Most of these finds ready application in aircraft, automobile and general engineering industry. CNC is used to control several types of machine today. Some of them are listed below. Machining center, horizontal, vertical, universal. CNC turning center or lathe, turn mill center, CNC milling or drilling machine, CNC gear hobbing machine, gear shaping, a wire cut EDM, CNC tube bending, electron beam welding, laser or arc or plasma cutting, coordinate measuring machine, grinding machine, tool and cutter grinding, CNC jig boring machine, PCB drilling machine, press brakes. Horizontal machining center. In this video, we are going to see about the types of horizontal machining center. Horizontal machining centers are generally single spindle machine with automatic tool changer. Some exception consist of machine with turret type tool magazine, combination of horizontal or vertical spindles, etc. Horizontal spindle machining centers are generally bed type machines with the structural configuration as shown. In this type of machining, X-axis traverse is provided by a table or column and Y-axis traverse is provided by spindle head. The Z-axis traverse is provided by the saddle or column or headstock or spindle head. The axes of the machining center are also shown. These machines are invariably used with a rotary indexing table to facilitate multi-phase machining at different angles in a single setup. The axis of the rotary table is parallel to the Y-axis and is called B-axis. The rotation of the table can be used for machining contours on surfaces of workpieces located on the rotary table, if CNC control is available for B-axis. Some horizontal machining centers are equipped with several pallets. Each pallet can carry a workpiece. This will ensure several hours of uninterrupted operation of the machine without the need for operator intervention. Vertical Spindle Machining Center. In this video, we are going to see about the typical vertical spindle machining center. Vertical Spindle Machining Center. Vertical Spindle Machining Center carries a vertical machining head which can be slid along the vertical guideways provided on the column. And also the vertical head can be slid to up and down along the vertical axis, that is Z-axis. The vertical spindle machining centers are also bed-type machine with single spindle and auto tool changer, multi-spindle with turret head. In vertical spindle machining center, X-axis traverse provided by table or collar, Y-axis traverse provided by the saddle or collar, Z-axis traverse provided by the headstock. Vertical spindle machines are not suitable for large width as this increases the throat distance. For very large width horizontal spindle configuration or bridge type configuration, that is double column planar type, is used. Universal Machining Center. In this video, we are going to see about the Universal Machining Center. These machines are similar to horizontal machining centers but with the spindle axis capable of tilting from horizontal to the vertical position or vertical to horizontal position continuously under computer control. This constitutes the fifth axis of the machine. In some cases, the movement is provided by tilting of the table instead of the spindle. Such machines facilitate access to the top surface of workpiece mounted on the table in addition to the multiple sides in a single setup. The fifth axis facility is essential for machining of some components which require the cutter axis to be perpendicular to the surface being machined. Machining center can be easily integrated into a flexible work awl. Provision of bidirectional random memory tool magazines, magazine changers, advanced tool management techniques, tool breakage detection techniques, devices for automatic workpiece loading and unloading, etc., are useful to realize unmanned operation of machining centers. Definition of CNC part program. In this video, we are going to see about the definition of CNC part program. Definition of CNC part program. CNC part program is a detailed list of instructions that need to be executed by the machine control unit, that is MCU, to achieve the final component shape. CNC programmer should have a fair knowledge about the machine tools, cutting tools and fixtures to be used and the manufacturing process. Methods of part programming. There are two methods of part programming, namely manual part programming, computer-aided part programming. Manual part programming. The process of generating part program manually by a part programmer is known as manual part programming. Computer-aided part programming. The process of generating part program partly by the part programmer and partly by computer is known as computer-aided part programming. Steps involved in CNC part programming. In this video, we are going to see about some of the steps involved on CNC part programming. The total steps involved in the development of a part program and its proving is shown in following flow diagram. Tool selection, cutting process parameter planning, job and tool setup planning, machining path planning, part program writing, part program proving, process planning. Planning is a detailed planning of the steps involved in manufacturing, that is, machining a given part. The following are the planned in process planning: machine tool used, fixture required, sequence of operations. For each operation, cutting tools required, process parameter, axis selection. To produce any machining profile, it is necessary to follow a proper coordinate system. To correctly describe the motion, it is necessary to establish the axis system to be followed with a particular part. Tool selection. The choice of cutting tools is a very important function, since for a given operation, many tools are feasible, but some of them are more economical than others. Therefore, in the economy of manufacture, it is essential to choose the right tool for the job. Cutting process parameter planning. For a given tool and the operation selected, the appropriate process parameters are to be selected. These are to be generally taken from the handbooks supplied by the cutting tool manufacturers or based on the shop experience. It is important in the context of CNC manufacture that the feeds and speeds selected should be as high as possible to reduce the machining time consistent with the product quality achieved. Job and tool setup planning. This is basically aimed at setting the job on the machine tool and adjusting the cutting tool to the correct position. This is important since the accuracy of the geometry generated by the CNC machine tool is dependent on the initial position carefully defined. Machining path planning. This is a very important aspect of programming wherein the knowledge of machining operations plays a vital role. A careful planning of the tool path ensures that the request manufacturing specifications are achieved at the lower cost. Part program writing. This aspect deals with the actual writing of the part programs, undertaking the format and syntax restrictions into account. Part program proving. This is another aspect. In this, the programmer should verify the prepared part program carefully before the part program is released to the machine tool. NC Word. In this video, we are going to see about the numerical control system. The part programming contains the list of coordinate values along the X, Y, and Z directions of the entire tool path to finish the component. The program should also contain information such as feed and speed. Each of the necessary instructions for a particular operation given in the part program is known as an NC word. A group of such NC word constitutes a complete NC instruction is known as block. The commonly used words are N, G, F, S, T, and M. The purpose of various alphabets used in CNC part program is listed in below table. Structure of word address format. A common format is the word address format, that is N, X, Y, Z, I, J, K, F, S, T, M. The letter denotes a type of instruction or instruction parameter. Underscore is a number that gives the instruction number or parameter value. Letter and number pairs, that is words, can be omitted if they have not changed from the last command. Example of word address format: N0040, G01, X0, Y0, Z10. It means move the tool 0 distance in X and Y axis and 10 distance in Z axis, where N is the sequence number, G is the preparatory command, that is move instruction. X, Y, and Z are relative or absolute coordinates of the cutter. Preparatory functions, that is G codes. In this video, we are going to see about the preparatory functions, that is G codes. Preparatory functions are denoted by alphabet G. G codes deals with the movement of tool. This word is used to prepare the instructions for controller to control the machine tool movements. It starts with the letter G followed by 2-digit number. Example G00, where G denotes preparatory function, 00 denotes linear tool motion in rapid. Function used to move the tool from one point to another point without cutting action. The other G codes and their functions are listed below. Motion group: G00, rapid positioning; G01, linear interpolation; G02, circular interpolation clockwise. G03, circular interpolation counterclockwise. Active plane selection group. G17, XY plane selection. G18, XZ plane selection. G19, YZ plane selection. Cutter compensation group. G40, cutter compensation cancel. G41, cutter radius compensation left. G42, cutter radius compensation right. Unit group. G70, inch units. G71, metric units. Hole making canned cycle group. G80, canned cycle cancel. G81 to G89, canned cycle definitions and on. G83, peck drill cycle. Coordinate system group. G90, absolute coordinate system. G91, incremental coordinate system. Preset. G92, absolute preset. Change the datum position. G94, feed rate millimeter per minute. G95, feed rate millimeter per revolution. G96, constant cutting speed. Miscellaneous functions, that is M codes. In this video, we are going to see about the miscellaneous function, that is M codes. M codes are called miscellaneous function, deals with operation of machine. Generally, only one M code is supposed to be given in single block. Some controllers allow for 2 or more M codes to be given in a block, provided these are not mutually exclusive. It starts with the letter M followed by a 2-digit number. Example, M02, where M denotes miscellaneous function. 02 denotes end of program. Function code tells the controller that the end of the program has been reached. The other M codes and their functions are listed below. Code function. M00, program stop, spindle and cool and off. M01, optional programmable stop. M02, end of program, often interchangeable with M30. M03, spindle on CW. M04, spindle on CCW. M05, spindle stop. M06, tool change. M07, coolant supply number 1 on. M08, coolant supply number 2 on. M09, coolant off. M10, clamp. M11, unclamp. M12, unassigned. M13, spindle on. CW plus coolant on. M14, spindle on. CCW plus coolant on. M15, rapid traverse in plus direction. M16, rapid traverse in minus direction. M17 to M18, unassigned. M19, spindle stop at specified angular position. M20 to M29, unassigned. M30, program stop at end tape plus tape rewind. M31, interlock bypass. M32 to M35, constant cutting velocity. M36 to M39, unassigned. M40, M45, gear changes, otherwise unassigned. M46, M49, unassigned. M50, coolant supply, number 3 on. M51, coolant supply, number 4 on. direct numerical control, that is DNC. In this video, we are going to see about the direct numerical control, that is DNC. Direct numerical control, that is DNC, can be defined as a manufacturing system in which a number of machines are controlled by a single computer through direct connections and in real time. Typically, one large computer can manage a few hundred machine tools. On some CNC machine controllers, the available memory is too small to contain the machining program. For example, machining complex surfaces. So in this case, the program is stored in a separate computer and sent directly to the machine one block at a time. If the computer is connected to a number of machines, it can distribute programs to different machines as required. Usually, the manufacturer of the control provides suitable DNC software. However, if this provision is not possible, some software companies provide DNC applications that fulfill the purpose. DNC networking or DNC communication is always required when CAM programs are to run on some CNC machine control. DNC has four basic components. They are central computer, bulk memory to store part programs and instructions, communication lines between computer and machines, NC machine tools. Functions of DNC system. In this video, we are going to see about the functions of direct numerical control system. Typical functions served by a DNC are communication, part program storage, ancillary functions. Communication. This provides two-way communication between the CNC machine and main computer as following. Sending part programs to NC machine tools. Serve as a buffer to storage large part programs. Download tool offsets and length information from the machine tool. Control the NC machine remotely as required. Part program storage. There are a large number of functions that can be carried out by a DNC computer that cannot be done on the MCU. It can store all programs as the storage is quite large. It can input, edit, copy, and delete programs much faster than MCU. Editing can be done on multiple lines, that is blocks of program, rather than a line feed as in MCU. After editing, renumbering of program lines takes quite a time. DNC computers can do this automatically. Many functions like calculating machine parameters, syntax checking can be done with much ease. Complete tool management functions like tool offset, length, life, wear can be embedded into the DNC computer. Ancillary functions. DNC systems can help to accomplish integrating with CAD or CAM systems for latest design updates, changes. Integration with shop floor systems for better machine utilization throughout worker safety. Constant control over the performance of the machine tools and diagnosing the possible problems before they lead to machine shutdown. Keeping track of production performance like number of components machined, machines used, etc. as shown in figure below. Advantages of DNC machine. control of one machine at a time. Remote control of machines is possible. Elimination of tape and tape reader. DNC software helps in managing the part programs in a better and easier way. Greater computational capability and flexibility. Establishes the framework for the evolution of the future. Applications of CNC machines. In this video, we are going to see about the application of computer numerical control machines. It is not necessary that all of the above factors should be considered while making a part on a CNC machine. However, the following industrial parts are usually made profitable on the CNC machines. Aerospace equipments. Aerospace industry is one of the first and greatest users of the CNC machines because of the small batches of complex parts are needed by it. Printed circuit board, that is PCB. The electronic industry uses CNC to manufacture and assemble component parts on PCBs. Coil winding. The electrical industry uses NC to wind coils for different types of motors and transformers. Automobile parts. This is the second largest industry to use CNC machines. Textile products. NC sewing and pattern design machine extensively use CNCs. Leather products such as shoes, hats,